In this video, we will be looking at the proving of trigonometry identity, which is a very common question that is tested in O-level at math. So we are going to use this as an example to show you how to do proving question for your O-level additional math. So let's get started. Alright, so in this question, we are asked to prove this identity. So we know that we have 1 plus sine 2x plus cosine 2x over cosine x plus sine x equals to cosine x. So we know that we have double angle here, and what we need to prove at the end of the day is angles in terms of x. So in other words, very likely we need to make use of the double angle formula. Alright, so let's start off from the left hand side and we will move towards the right hand side slowly. Okay, and we know that we need to use the double angle formulas here to change the angle here to x. So we start off by copying what is on the left hand side of the equation, which is 1 plus sine 2x plus cosine 2x over cosine x plus sine x. Okay, then I know that sine 2x is basically equals to 2 sine x cosine x. Don't memorize this. This is in your formula booklet. And cosine 2x, you have three choices, right? You have cosine square x minus sine square x, or you have 1 minus 2 sine square x, or you have 2 cosine square x minus 1. Okay, so if you were to look at this, right, very likely I'll make use of this. Okay, because in order to prove that it's equals to cosine x at the end of the day, probably I do not need this 1 here. So to get rid of this 1 here, I will have this minus 1 here so that I can get rid of this 1. Okay, it might sound weird now, but let me show you what I mean by doing it. So now I will change sine 2x to this. This is the only choice you have in your formula booklet, so just use it. For cosine 2x, I'll use this one because I want to get rid of my 1 here. So minus 1 plus 1 is 0. So that is why I choose this. Okay, so let's do it. So I'll change sine 2x to 2 sine x cosine x. And I'll change cosine 2x to 2 cosine squared x minus 1. Okay, just copy the denominator. There's nothing much I need to do for now. So next, I have a minus 1 and a plus 1, so they'll cancel off, right? So now I'll be left with 2 sine x cosine x plus 2 cosine squared x at the numerator. For the denominator, I have cosine x plus sine x. I know that I do not want this cosine x plus sine x, right? Because I have no denominator here on the right hand side of what I need to prove. So now let's take a closer look at the numerator. You notice that, right? This term has 2 cosine x. This term also has 2 cosine x. So we can factorize out 2 cosine x. And what we'll be left with will be sine x plus cosine x. Okay? So we know that it is sine x plus cosine x. This is also sine x plus cosine x, and we can cancel them. So we'll be left with 2 cosine x, which is what we need to prove, okay, for the right hand side. So we have proved this identity.